So here's just a general practice problem. For the region R bounded by the x-axis, the line x equals 2 and the graph of y equals x squared, find the volume of this solid generated by A, rotating R about the x-axis, B, rotating R about the y-axis. Take a stab at that if you're starting to feel confident. Otherwise, you can hang out and just watch. All right, so whether you've tried it or not, I always recommend starting with a sketch. Like, you don't really have to draw these, but I find it helpful to really know what you're dealing with. So we have y equals x squared. All right, x squared, and we have x equals 2, and we have the x-axis. So this is our region right here. All right, it's easy to figure out that this is the point 24, and that's going to give us our limits of integration in both cases. So the first one, part A, is we're going to rotate this about the x-axis. So we're going to reflect it over the x-axis. It's just going to look sort of like this. All right, and we're spinning it around. So it's like a trumpet, but it's solid, so it's like a funnel. You know, some kind of a sideways funnel, like a tornado, but sideways, and solid. All right, remember this thing is solid. So it's like you take your trumpet horn, you fill it with silicone, and then you let it dry, and then you pull out the silicone. I think I have totally flubbed the idea of this shading. I don't think I can do it. Anyway, there it is. It's like a flary trumpet. Okay, so rotating it this way, we have to think, you know, is it X, is it Y, is it simple, is it compound? Doesn't have a hole through it, so it's a simple shape. All right, it's rotated around the x-axis. So look up your formulas from the notes. You're going to use v equals pi integral a to b of f of x squared dx. So that's pretty easy to do. You're going to do, pi times the integral from, these are x coordinates, so 0 to 2, the x coordinate, 0 to 2. Integral 0 to 2, my f of x is x squared, but I have to square it, dx. So I have pi integral 0 to 2, x fourth dx. So I have pi times the evaluation of x fifth over 5 from 0 to 2. So that's 32 pi over 5. See how easy peasy that gets to be once you get it. All right, now let's do part B. So for part B of that, we have the same shape. And this is the one I really wanted to show you because it's a little bit tricky. So if you got this one, good for you. I've got the line x equals 2 out here, and this is y equals x squared. I'm rotating it about the y-axis, so what I have is like this cup shape on the inside, but the outside is a cylinder. So basically, this is like a cylinder, and I've drilled out a cone-shaped hole from it. So this cone-shaped hole is like going down like that into there. But the outside is a nice flat cylinder. Nice flat all the way around. All right, that's my cylinder shape. But yeah, inside, sort of like I gave it a lip. It does not have a lip. But that cup is like cut out, dug out into it. So you take a can and you scoop out something. This is like, you know, you got like a big can of ice cream and you started scooping out the ice cream. And this is the shape that's left. This is the volume of ice cream that is left. And that is an important question because we need to know how much ice cream is left. All right, so what are we going to do with it? So here's this one has a hole in it, right? It's not simple. So this is actually a compound shape. It's not obvious, though, because it's not obvious what the outside function is. But this region y, like in the x direction, is determined by the x-axis and the function. But in the y direction, it doesn't go back to the y-axis. This shape in the y direction stops here at the line x equals 2. That's really a function. In fact, that's g of y. That's the outside function. And then the inside function is this function in here, y equals x squared, which we need to solve for y and get x equals square root y. That's my f of y is square root y. All right, so I really have two functions. The outside function is just g of y equals 2. The inside function is f of y equals square root y. Remember, I have to solve the equation for x because I'm integrating with respect to y. All right, so then my volume formula is pi times the integral from, now, I guess we'll go ahead and write it, a to b of g of y squared minus f of y squared dy. All right, and that is the integral from, so remember these are y coordinates now, y coordinates because we're dy, y coordinates. So we're going from 0 to 4 because this is the point 24 up here. So 0 to 4. So my limits of integration are 0 to 4. My g of y is 2, so I have 2 squared, minus my f of y is square root y squared. Right, so you notice how we don't mind having square roots in our functions because we're just going to square them anyway. So that is pi integral 0 to 4 of 4 minus y dy. What could be easier than that? It's pi 4y minus y squared over 2. We're going from 0 to 4. The 0 gives us zeros, so we can just go 16 minus 16 over 2 is 8. It's 8 pi again. Ta-da! All right, that's the volume. So that's volume with respect to y, volume with respect to x. So this one, this particular shape, all of this came from this one shape, this region R, which looks like this, right? So if I rotate around the x-axis, it's a simple shape. It does not have a hole, so we can use the simple formula. But when I rotate it with respect to y, it ends up having a hole in it. So I need the compound formula because I have two functions. But be aware that sometimes one of the functions is just a constant. That's what happened in this case. It's just that constant x equals 2. So that second function was kind of hidden in the boundary line. That boundary line, when you rotate with respect to x, all it's giving you is the limit of integration. It's giving you this 2 right here. But when you do with respect to y, that actually becomes a function. It becomes one of the bounds of, really, if you like, think of that ith element. That ith element is going from the square root function out to x equals 2. Yeah. So, all right, there you go. So, again, the bookwork is sort of a little scrambled. We will come back to the bookwork after we're sort of solid with each of these types of problems independently. So I'm giving you volume practice number 1 and number 2. I think they're organized in some kind of way that volume 1 is like the simple shapes and volume 2 is the complex shapes. So for now, I'm sort of separating them out for you. And then once we're solid, no pun intended, once we're solid with this, we will mix them up a little bit more. All right, enjoy.